So annoying. Pi over 12. If we type that into our calculator, what do we get? For a degree. What do we get for a degree? Pi divided by 12. How do we convert? Multiply by 180, divide by pi, right? What do you get as a degree? 15. So we're looking for sine of 15. Now, we can type that in. You can type in sine of pi over 12. Do that right now, but make sure you're in what mode if you're typing in sine of pi over 12? Radians, right? So type in sine pi over 12 into your calculator in radian mode. And keep that decimal in your head. Okay? So you got a nice little decimal. The catch is this one says determine the exact value. Is a decimal an exact value? No. An exact value screams unit circle. So you go to your unit circle and you're like, 15. I have no idea. That's not on my unit circle. True. But is there anything on my unit circle that I could possibly add or subtract, that would get me 15? Anything on your unit circle that you could add or subtract? Any angles that would get you 15? 30 and 45, 60 and 45, 135 and 150, right? There's a whole bunch, isn't there? That's going to get real annoying. I'm going to use 45 and 30. So I'm going to go sine pi over 4 minus pi over 6. Because I'm going to keep it in radians just because it was in radians, right? But I used the 15 to help me out. All right? Now, I've told you that the worst thing you could do at this point is, one second. Okay. So I'm not allowed to distribute. Remember when I have sine of two things, I have to stop myself from distributing because it's the thing that you're going to want to do the most of because you're just so used to when you have something outside of a bracket you can distribute, but you can't do that here. So what we actually have to do is go to our sum and difference formulas, correct? We have a formula for this. It's sine A minus B. Sine A minus B equals sine A, which is pi over 4, cos B, which is pi over 6, minus cos A, which is pi over 4, sine B, which is pi over 6. Okay, what is sine at pi over 4? What is the y at pi over 4? Root 2 over 2. Not sine of root 2 over 2. So many people write sine of root 2 over 2. No. Sine of pi over 4 equals root 2 over 2. I just replace it. What about cos of pi over 6? What does it equal? Then I have a minus sign. Then I replace cos of pi over 4. What's that? Root 2 over 2. And then sine of pi over 6? 1/2. Now, what you need to remember is, when you multiply radicals together, you multiply what's outside by what's outside and what's inside by what's inside. So the outside numbers and the radicands. So, if I go root 2 times root 3, that's root 6 over, and then this is where people mess up. They go 2, because they're used to common denominators, but it's actually 2 times 2, which is 4, minus root 2 times 1 is just root 2 over 4. And then, because I have a common denominator, which I always will have if I do this, I get a 4 and I get root 6 minus root 2, all over 4. Now type that into your calculator. Make sure you type the top in brackets if you're not using alpha y equals enter. So currently you should have sine of pi over 12 in your calculator in radian mode and get a decimal. And now you should be typing in root 6 minus root 2 over 4. What happened? They're the same. They should be the same decimal, right? Because tan or sine of pi over 12, when you typed it in, you just got a decimal, not an exact value, correct? That was the problem. That's why you couldn't give that answer, because I asked for it in an exact value. Now that we got exact value, if I turn that into a decimal, it should match, right? You should be able to walk away from these questions knowing, yes, I got it right, or no, I need to try again. And don't make it be that you're trying again because you literally had it in degree mode when you typed in sine pi over 12. Okay? Make sure you type it in the right mode, and then make sure that they match. You're trying cos 165. What are the two things that I could do to get 165? I could add 135 plus 30. You try that one. So the cos formula, this would be A, and this would be B of the formula. So we're going to go cos 135 degrees. And I put in brackets, so I make sure I replace it. If I put in brackets, most people won't write cos of the answer, because they do. You're like, no, I'll never do that. It happens about half. So don't do that. Cos 135 is just negative root 2 over 2, right? People will write cos negative root 2 over 2 all the time on their tests. And then we have cos of 30 minus sine of 135. Sine of 30. Cos 135 is negative root 2 over 2. Cos of 30 is root 3 over 2. Sine of 135 is root 2 over 2. Sine of 30 is a half. So I'm going to get negative root 6 over 4 minus root 2 over 4, which gives me negative root 6 minus root 2 all over 4. Now I should be able to punch that into my calculator, and I should be able to punch cos 165 in degree mode into my calculator, and they should match, right? Their decimals should match. Okay, the next one is tan. And if you haven't noticed, tan is the ugliest formula on there. I don't have it memorized because I choose not to. So tan of 105. What are the things that I could put together that would get me tan 105? Any? Can I add things or subtract things? Or, yeah. Yeah. So I could go tan 135 degrees minus tan of 30. Oops. Minus 30. Now this would be A and this would be B. So that would go into my minus tan. So I'd get tan of 135 minus tan of 30 all over 1 plus tan 135 tan of 30. What's tan at 135? So if I go to 135 and I divide them, it's going to be negative 1. So I'm going to write this up here to help myself out. Tan of 135 is negative 1. What's tan of 30? Root 3 over 3. Because you're going to get a half divided by root 3 over 2, which is a half, times 2 over root 3, which is 1 over root 3, multiplied by root 3, which is root 3 over 3. Remember I told you tans of 30s are root 3 over 3, tans of 60s is just root 3. It's worth memorizing. If not, you're going to have to do this every single time. So, you can fill it in. We're going to get negative 1 minus root 3 over 3. And immediately I have a fraction in my numerator, right? So when I have a fraction in my numerator, I write it in its own brackets, and I'm going to write numerator side by side to my denominator. So if I get a fraction in my numerator or I get a fraction in my denominator, I write them side by side. So I'm going to get negative 1 minus root 3 over 3. And then I get positive 1 plus root 3 over 3 times negative 1. Or negative 1 times root 3 over 3. I put them out of order. So here I have negative 1 minus root 3 over 3 divided by 1 minus root 3 over 3. Now, some people want to flip. Am I allowed to flip? No. What I tell you, you have to watch yourself. You have to have full fraction divided by full fraction. Do I currently have that in my brackets? Is each bracket a full fraction? No, so I need to make them full fractions. So this is technically over 1, and so is this. So I can't put them together. I have to make it a common denominator, so I have to multiply this one by 3 and 3. And I have to multiply this one by 3 and 3. So I'm going to get negative 3 over 3. I'm going to show the step, but you wouldn't have to. Minus root 3 over 3 divided by 3 over 3 minus root 3 over 3. And now I have common denominator, so I can put them together. Negative 3 minus root 3 all over 3 divided by 3 minus root 3 all over 3. Now, on both sides of those division symbols, do I have full fraction divided by full fraction? Yes, this is one whole fraction, that's one whole fraction. Only until I have that, now I can flip and multiply. But that has to happen first. So I'm going to get minus 3 minus, or negative 3 minus root 3 over 3 times 3 over 3 minus root 3. These 3's can cancel, but that's the only thing that can cancel, because these don't match at all. They look similar, but they have to be the exact same in order to cancel. So if this was a 3 minus root 3, then I could cancel them. But because they're completely different, I can't. I have to go negative 3 minus root 3 over 3 minus root 3. And now I have to bring back grade 11. We always end with bringing back grade 11 or 10. It's our things. That's how we roll. So I can't have a square root my denominator. If I had just one square root, I would just multiply by it. So if I had just had root 3, I can multiply by root 3 and it would go away, right? When I have a binomial in my denominator, I have to multiply by the conjugate. So I'm going to have to multiply by 3 plus root 3. And the reason why you do that is your middle terms go away when you multiply by a conjugate. It's like a difference of squares factors. So I get 3 plus root 3. I have to do the top and the bottom. So when I do it to the top, I get negative 9. Minus 3 times root 3 is minus 3 root 3. Minus 3 times root 3 is minus 3 root 3. And then negative root 3 times root 3 is minus 3. All over 3 times 3, which is 9. 3 times root 3 is 3 root 3. 3 times negative root 3 is negative 3 root 3. And this is why you multiply by the conjugate, because your middle terms go away. That was the point of it. Because you get one positive and one negative. And then you do minus root 3 times root 3 is minus 3. So on the top, I have negative 9 minus 3, which is negative 12, minus 6 root 3 over 6. And then what can I do? Did this last year too in grade 11. Simplify it. It has to come out of all 3 or it can't happen, right? So I can take a 6 out of all of them. And I get negative 2, negative 1, and 1. Do I have to write a 1 if it's the denominator? Nope. So I get negative 2 minus root 3. Now, if I typed into my calculator, I'll come back to that in a second. If I typed in tan 105 in degree mode, type that in, tan 105 in degree mode. And then type in -2 minus root 3 into your screen. Then you're typing in -2 minus root 3 into your screen. And what do you get? Same thing? So you know you're right. This is obviously the ugliest thing you can be given, but expect that it could be something you can be given. So we're using grade 10 and 11, and we're using 12 to start it with the trig. Yeah?
I got different numbers.
Are you in degree mode?
No.
That's your problem.
Sorry.
So honestly, most people will, when they check, the check is good because it can make you feel good that you got it right and move on. The problem is some people will do their algebra right and then they'll punch into their calculator in the wrong mode and they'll be like, I did it wrong, and then they erase it and redo the whole thing a whole bunch of times, when in reality you're just typing into your calculator wrong. So don't be that.
I still got a different answer.
Did you go -2 minus root 3 or did you go -2?
I did -2 minus root 3.
Enter. And then you did tan 105.
Do I go second tan?
Nope.
Oh. Yeah, I got the same answer.
You only second tan when you're trying to find an angle.
Oh.
So when you have like tan theta equals a number and you're trying to get theta by itself, that's the only time you second tan. Let's get the tan away from the theta. All right, next page. Okay, these two are bringing chapter 4 back and embedding it with chapter 6. So I'm going to actually do example 6 first. Sounds stupid, but I'm going to do example 6 first. And to be honest, I want you to change this to a cos, please. It's a typo. Cos x. Oh, no, it's yours is a cos. It's supposed to be a sine. Change it to mine. Change it to what I have. I fixed the notes after, but this needs to be sine x equals -4/5. And it needs to be from 90 to 270, please. I think you have a cos. I want it to be a sine. It has to look like that. Sine x equals -4/5 from 90 to 270. Yeah, I want -4/5. So you're changing it sine, you're changing it to -4/5, and it was 180 to 270. I want 90 to 270. So what happens when I give you a trig ratio and where it could be found? What do? You draw a, anyone remember? Chapter 4. Trig ratio, where it could be found, you draw a what? Triangle. Every single time. So this is sign your resume. So it's sine negative, and it can be found from 90 to 270. Which one of these is sine negative from 90 to 270? So this one's out, and this one's out. Which one of these is sine negative? Quadrant 2 or 3? 3. Because sine is positive due to cast in quadrant 2, right? So it's here. And it's your resume, so it's -4 and 5. And my x is going to be negative because I drew my triangle to know that my x is going to be negative, right? How do I find the third side? Pythagorean theorem. So none of this is new. This is all chapter 4. I'm just repeating chapter 4. So I'm going to go x squared equals 5 squared minus -4 squared. X squared equals 25 minus 16. X squared equals 9. X equals plus or minus root 9. X equals plus or minus 3. And in this case, it has to be -3. And if you don't draw the triangle, you're not going to know which one to pick. It can be like a 50-50 guess if x should be not negative or positive, and we don't want that. So that right there is chapter 4. Chapter 4, then I would just follow behind and ask for like cotan, or I would ask for cosecant or something, right? Of it, and you just give your trig ratio. But chapter 6 uses chapter 4's information to get me all that information. But now it wants cos x plus 150. And what do I absolutely not do when this happens? That is some serious piano. Whoever's doing it is playing beautifully this time of year. It's not distracting at all. What do I not do?
Distribute.
I do not distribute. Yeah, you stop yourself. You slap your hand and be like, do not distribute. Because you want to know how everyone gets this wrong? They're like, boom, I got this. Cos x plus cos 150. And then boom, they give me an answer and it's wrong. It's sad. It's so sad. Do not distribute. Be like, okay, I can't distribute. So what can I do? Go to my formula sheet. This is cos A plus B. You fill into the cos A plus B formula sheet. Formula off the formula sheet. So it's going to be cos A, which is x in this case, times cos B, which is, 150. Minus sine x sine 150. I just want to know who's playing. They're really good. Anyone? Anyone have a guess? Well, that was eventful. Okay, now we all know someone. I'm going to do a student of the day. I don't know who on Thursday. We're going to see who knows. I'm going to maybe give out a medal for the person who knows the most people. I'm not sure yet. I'm going to think about it. I have a whole day. I will come back on Thursday and report back to you. And by the end of the semester, maybe we do 2 students a day, you will know who's in your class, and you won't be shameful when I'm like, hey, can you hand this to, like, Belle? And they're like, who's Belle? I don't know who Belle is. But everyone knows who Belle is. Belle's over there. She can shake. Wave your hand. Yeah, there we go. Shaking hands. That's Belle. This is Michael Peloso. He's one of 9. Right?
Yeah.
That's the first time I've remembered. I've usually shot around with the wrong number. Okay. All right. Cos x. Cos x is what? Remember, this is triangle x, right? What's cos of x? Cook extra rice. Cook extra rice. What is extra rice on the graph? Negative 3 over 5. We actually picked, I did the hardest one first, because the rest, you all know. What's cos of 150? Go to 150. Negative root 3 over 2. Minus, what's sine of x? And if you can't give me that one, which honestly sometimes is left blank, which kind of blows my mind, it's listed in the question. Sine x equals negative 4/5. It tells you what it is. So we're going to input that. Sine 150? 1/2. So in this case, you use the triangle to get you the odd trig ratio because it's an x triangle, and you use your unit circle to get you the other stuff, right? And then we can put them together. So minus a minus is a plus, so we get 3 root 3 over 10 minus negative 4 times 1 times the negative. Well, we'll just do this. So negative 4 over 10. And then we have a common denominator, so we get 3 root 3 plus 4 all over 10. Okay, so part triangle, part unit circle, right? The next one, so we get 1 trig ratio, we have to make 1 triangle, correct? Da da da! 2 trig ratios. What do you think we're going to get? You're not nearly as excited as I am about this. 2 triangles. Yes, we are. Faux show. So we have cos A, and A, they tell us, is between 0 and pi over 2. So that's quadrant 1. So here, and we label this triangle A, just like we labeled that other one triangle X. This is triangle A. What did they give us about, what's up?
Do you have to draw triangles?
You don't, but triangles will often cause the person who puts the wrong X or Y sign to stop doing that. Yes. So, cook extra rice. So we have a 3, we have a 5, we need to find the X. So we do X, that's not an X. Why did I do Y? Y squared equals 5 squared minus 3 squared. Y squared equals 25 minus 9. Y squared equals 16. Plus or minus, plus or minus. In this case, y equals 4, because it has to be positive to be here. Triangle A, done and done. You do triangle B, and go. Triangle B. I had a grad class of 42. I actually knew almost every single person from grade 3 to 12 in my school. So you guys can learn your 300 people in your class, okay? So look up who I'm going to make my next.
What if you transfer to a school?
You can still learn. You can still learn. Next time I'm going to actually ask the human, though, before I show their face. But this one was like a way amazing human, so I think you can learn. Who am I going to ask? I'll pick randoms. They have to be someone I have, though, because I can't show pictures of people I don't have. So. And I have them all before your class, so I have time to ask them during the day. So we have triangle A, we have triangle B, and you could give any trig ratio off of any of these, right? Like if I asked for cos, if I asked for tan, if I asked for cotan, you would just use like tan your x box or cotan x box your, you know? All right. Now, that's all chapter 4. That's nothing from chapter 6, right? That's all chapter 4. Chapter 6 comes in where it says, find the exact value of cos A plus B. That's the chapter 6. So cos A plus B. And what you need to stop yourself from doing is distributing. Do not say cos A plus cos B. It is wrong. It is bad. You should get a really bad math ticket. Like at least $1,000 ticket for doing that. That's how bad it is. So we're going to go to our formula sheet. And our formula sheet says cos A times cos B minus sine A sine B. What's great about this, they already gave us cos A and cos B, right? It's in the question. Cos A is 3/5. Cos B is 5/13. The sum and difference formula should always get you nice common denominators. If you don't have common denominators on both sides of that minus sign or plus sign or whatever's in the middle, oopsie. It'll always get you common denominator. So what's sine of A? Sine your resume. What's triangle A? 4/5. And then what's sine your resume of triangle B? -12/13. So I'm going to get 15/65 minus a minus, so positive 48/65, which equals 63/7. Yeah? Das ist gut. Sprechen Sie Deutsch. That's all I have. Oh, I have some other words, but they're not appropriate. My grandpa used to speak German, and my dad could understand German. So then when we weren't supposed to hear things, he'd speak it in German. So now all I know is useless things that are not good to say in German. Thanks, Dad. Went to Germany, they'd all just tell me no. Voila. You're welcome. De rien. En français. Page 306. 8 BCE, 10, 11, 17, 19, 20. And you have some time to work on them, which I never give you. So you are welcome. It's a gift. Do not pack up. That would make me sad.